What's up, guys? Quinn with 74 Weld here to give an update on a new product line, a couple different product lines that we are launching now. I'll start on my right and talk about links, and then we'll get into arms. And I guess my goal on this stuff is, I guess I should talk about my thought process on developing products. As a rule, I don't really want to develop a product if there's already a good solution on the market that I like. It doesn't mean that our stuff is, I'm not going to sit here and say, well, ours is better than everyone else's. What I will tell you is that ours is different, and there are specific reasons why I've done stuff the way that we have. And I'll kind of dive into some of that. So in front of me right here, these links are for a Ranger Raptor. This is going to be lowers, uppers, and Watts link pivot stuff. And I see a trend that has been around for a long time in our industry, which is when guys go to aftermarket stuff, they're either going to go tube steel, totally fine, it's a really good solution, it's the cheaper, easier, or they'll go aluminum. But typically, regardless of which route they go, most of the aftermarket options for you are going to run Heim joints and uniballs. And those parts have been around for a long time. They're super common. I think there's a misconception about Heims and uniballs. I like them for certain things. I hate them for other things. So a Heim joint or a uniball is going to be an extremely high load rating. What maybe people know and they ignore, or maybe people don't know, is that like you're going to find Heims and uniballs on every race car. Maybe what you don't know is that that car gets raced once and all of the Heims and uniballs get torn off the car, put in the trash, and all brand new ones go on. So my gripe with suspension stuff that's out there right now is from a longevity standpoint. It's not durability, it's longevity. So when I talk about these two concepts, durability is, I'm going to refer to kind of toughness, like, you know, what can it really handle? Longevity is just that. Is it going to go 5,000, 10,000, or is it going to go 100,000? I don't want anything on my vehicles that I have to change out in 5,000 miles. Because on a lot of upper arms or links, you have to unthread the Heim, thread in a new one. Now you've got to readjust all of your links. And you can pull tape on that, and there's tricks to get around that stuff. But if I was going to do a line, my thought was I didn't want to do it around that. So we're launching a line of aluminum links right now for Ranger Raptor. It's kind of what we started on. I have a Ranger Raptor. I love the truck. And there were a couple things that I thought needed to be addressed. So if you're going to get Ranger Raptor links from me or from anyone else on the market, make sure you have something on the chassis side to keep it from wobbling. Our Ranger Raptor links are all machined aluminum. They're 6061. We have a spot for your factory live valve, and we have some Delrin spacers sleeves that keep the chassis side from ever wobbling. If you put a uniball on the chassis side of this lower link and it can rotate, you can invert your live valve sensor and break the whole sensor off. Ask me how I know. So standard on all of our stuff, a wobble stopper on the chassis side. On the uppers, fixed joints. You're not really messing with the Ranger Raptor trying to cheat suspension one way or the other. A 37-inch tire on a Ranger Raptor fits at full stuff without cutting rear flares at all. I do know this from personal experience. So our links, good up to a 37. The only way you fit 37s on a Ranger Raptor is with portals. We can help you with that. The Watts link pivot, we're doing, essentially these are replacement components of your OEM stuff. We'll get into I guess, before I dive into the Watts link or the physical pivot link, because this has a bunch of cool little things on it, I want to talk about joints. So I've kind of looked around the industry for a while. If your criteria is I don't want Heims or uniballs, there's a bunch of other options. I think the Curry Johnny joint is a great solution. There's a bunch of other companies that make really good joints. I'm kind of lazy on maintenance on stuff. The Curry stuff is tried and tested, it's Rock Jock now. Developed by John Curry a long time ago, super good joint. It does require grease. That was one of the things that I wanted was, I don't really want to grease stuff. And sometimes you get in on factory brackets and you can't actually get to the grease fitting. So now you're talking about dropping the link and then greasing it. I didn't want to go there. So, arguably, I think one of the best selling points of our links is actually a product that we don't make. About 3 years ago now, I was in Sand Hollow wheeling with some friends and was with Jeremy Purick, who's the owner of Rock Crawler Suspension. And I was talking about upper links on my 392, and I had clapped out the set that I had on there, and Jeremy says, hey, I'm going to send you a set of uppers. Try them. I think our joints are really good. I'll fast forward. That's 3 years on 40s and portals, and my links on my uppers on my 392 are still as tight as the day that I installed them. So what we're using across the board on all of our stuff is the Rock Crawler Adventure Series joint. It's essentially a semi-spherical, so it's a spherical ball that's captured in vulcanized rubber. And the reason I like vulcanized rubber is I don't think that any OEM vehicle, maybe short of the Raptor R, but any vehicle that we're developing for right here is going to put out enough torque or power to really destroy a good vulcanized rubber joint. I've had really good luck running these. I think they just have some cool features. So I'll talk a little bit about some of the features, and one of the reasons that I think the Rock Crawler joint stands in a different class. This is the Adventure Series Rock Crawler joint. So one of the things that Jeremy does is he has a semi-spherical ball captured in vulcanized rubber, but on the inside of this, he presses in a DU bearing. And then inside of that, there's a sleeve. And so the cool thing about DU bearings is that it's essentially a self-lubricating pivot sleeve. So you have metal, a DU bearing, and then a metal sleeve. And what it allows it to do is it doesn't wrench on the rubber. It freely pivots up and down. These joints, I believe Jeremy did a video on this on his YouTube a long time ago. They get like 30 degrees of movement, so they get a lot of flex out of them. But when they're pivoting straight up and down, they're going to move freely because they're going to pivot on the DU bearing. The problem with the factory joints is when you pinch everything together, it's physically pivoting on the rubber, so it's always adding, and you're basically trying to tear that rubber apart. That's kind of the reason that I guess that would be a drawback to the OEM joint. It's just there's no inner moving sleeve on it. So Rock Crawler Adventure Series joints, I'm a big fan of. We end up going through on our Watts link and we make some custom bushings so that we can have a free moving pivot, and you can see I'm pinching the inner sleeve and it's able to pivot in that DU bearing. So we carry the DU style bearings through everything, including on our Watts pivot here, which I'm going to cut apart to show a couple things. So we do sleeves on both sides because we want to be able to run the factory bolt into this pivot, The problem would be, is you have two options. If these two sleeves touch in the middle, then in theory, you could get a little bit of play back and forth on that pivot. That's not desirable. If they don't touch and you crush, now you're crushing that inner bushing. So what we do to mitigate this is we have the two sleeves that bottom out against each other. So you can torque this thing to factory spec, I think it's like 250 pounds. And these sleeves bottom out. What you end up with is a little bit of play. We didn't want that play in the system, so what we do is we take a Wave spring washer. These are made out of spring steel. We buy them off McMaster. And that takes up all of the slop. So this spring washer puts out, I think, 35 pounds to fully crush it. So it eliminates any of the play or movement in the Watts pivot, and you basically get one going one way, one going the other way. We also put, because for this pivot, we didn't want to go aluminum straight on the sleeves, so we have 17.4 heat-treated sleeves that slide into this. And so your steel is contacting that 17.4. We provide bolts in the kit that go through all that stuff, and then we kind of finish it off with a decorative cap. But we wanted to kind of have a turnkey, well thought out system. And we're going to be doing this across all platforms. I clearly have opinions on a lot of things. And to me, I think that for 95% of the people out there that are driving on and off-road, I think you're better served with vulcanized rubber in a good quality joint versus going to Heims. I have friends that live up in the Colorado area and Northern California who, I talk to quite a bit, and I've had this discussion. Heim joints in snow with dirt and road grime, maybe you get 5, maybe 10,000 miles out of them, and you start to feel a little bit of play. And as the reason Heims wear is what happens is you'll get dirt that lodges into, it's just road grime, let's call it, or regular dirt from running. And that will essentially eat the liner. So on a typical Heim joint, you have a Teflon liner that separates the inner ball from the outer body. Those are both heat-treated parts. That Teflon liner is easily eaten away by just dirt. It's normal wear and tear, but it's something that if you don't maintain them, then you get play in them and you'll start feeling that, especially when it comes to steering components. You'll feel play in your steering wheel, you'll feel play in the rear end of the vehicle. And so we just didn't want to do the same, rinse and repeat. And I think for most people, vulcanized rubber is a better option. So that's what we went with. Agree, disagree, that's fine. That's what all of our stuff is going to be based around. So I'll slide down and we'll start talking about A-arms. It's not something that's new to us. We did them years ago, and we're going to kind of relaunch a bunch of A-arm designs. I talked about a video about adding caster into A-arms and why most companies do it for aftermarket arms. We'll throw a link up to that video. These arms, we are allowing you to put more caster in, but not forcing you to. So I'll kind of explain a little bit of that. And I'll do that in a few minutes. But when it comes to A-arms, one thing that I see on the market is aluminum A-arms and fabricated steel A-arms almost always look different. When you see a fabricated steel A-arm, the physical cup of the A-arm is usually kicked. When you see a machined aluminum arm, the uniball cup, if they're running uniballs, is typically in line. You can get enough movement out of a uniball in most cases that that's okay, but I've kind of always said, like, well, if the angle of your physical joint differs between aluminum and steel, well, why is that? And the real answer is most arms are made on a 3-axis and they can't kick the uniball cup, and then they just machine them out and press a uniball in. And that's why they're running those 1.25" monster uniballs, is because they need additional angle on them, kind of because the angle wasn't put in right from the get-go. That's a function of the equipment that you have at your disposal. I get it. I guess I shouldn't come across as like critiquing what others are doing. I'm telling you that they should sit at the same angle, and most aluminum arms on the market don't. And the reason for that is because if you're doing a 3-axis milling operation, you can't kick the head to get that proper angle. And so they just upsize and run a larger uniball so that they can get more misalignment out of it. I didn't want to run uniballs. You'll see a common theme here. So on our A-arms, across all of them, this A-arm here is Ranger Raptor because we have it. We're in the process of developing for basically every independent vehicle that we support with a portal. We're going to make an A-arm for it because the main driver on this is I don't want to put additional caster into the A-arm, and that is what most aftermarket A-arms are going to do. You can put more caster or take caster out in ours, and I'll explain a little bit of how we do that. But our A-arms, like every A-arm on the market, they pocket them out, they look fancy. This comes down to personal opinions, what you like, what you don't like. Here's the difference between us and everyone else, almost everyone else. Once again, you'll hear a theme here. Jeremy Purick, rock crawler suspension, buddy of mine. We were talking about ball studs and pivots, and I didn't necessarily want to just run a press-in ball joint like a factory style, and on some of these new arms, either they're not changeable or there's not aftermarket support. And Jeremy says, hey, I've developed this thing, I've had it for years. We essentially use a Delrin, 2-piece Delrin race with a spanner nut so that you can tighten everything down, and we make our own ball stud, the ball stud for your upper ball joint. So this is a Ranger Raptor one. We made this ball stud here in-house. But what it allows us to do is run a 4340 through hardened alloy pin that acts as your taper and your ball joint, so there's no additional misalignments to stack up. It's better to have everything one piece. This gets captured in an injection molded race. It's then tightened down and we'll torque them to a spec. It's like 30 pounds. And what this allows you to do is you can put the ball joint in, you can tighten it, it's greasable, and if you ever do need to service it, and according to Jeremy, should be about every 30 to 50,000 miles, you'll pop the top cap off of this and you'll be able to retorque it. He's got a set with, I think he said 130,000 miles on them, and the races are still good, but it's also fully rebuildable. So if you ever needed to change the races out, the plastic parts internally, I think they're like $10 for a set of them. So it's fully rebuildable, it's greasable, and you can always tighten it if it ever wears out. Whereas a Heim or a Uniball, you're throwing away that $60 Uniball. Whereas this, you just pop our top cap off, tighten it, pop the cap back on, and you're done. So this is our connection point, and this will be our connection point for everything on all of our arms moving forward. The one other thing that we do, which only a couple companies in our industry do this, and this is not my gripe. This is a gripe that I have heard from installers all around, is typically you'll see that if you have an upper arm from an aftermarket company and they're running Heims on the chassis side, the Heims will just thread straight into the aluminum arm. That doesn't really matter that much to you, but the installers, when they're trying to align the vehicle, you have to physically take the arm off, unthread a couple threads, put the arm back on, check alignment. This is if you're going to pin your lower cam bushings, which I think is a good idea to do on everything. Then you never have to worry about your alignment. But in order to align it, you have to basically take the arm off and put it on, back on every time. So you'll see another theme here. I noticed that Icon, their arms don't do that. What Icon does, you can see this piece right here. They basically have a left-hand thread on the OD and a right-hand thread on the ID of this part. So as an installer, you can have your lower pivot cams locked, and you can sit there and you can adjust both camber and caster with everything on the vehicle. Lower pivot's locked, upper pivot's locked, and you can sit here and adjust your fine tune to get your alignment without taking anything apart on the vehicle. So I called the guys at Icon and I was like, hey, can I buy some of those double adjusters from you? And they said, sure. So an Icon part, a rock crawler part, a 74 Weld part. I like to work with people in the company or in the industry. And if somebody, I guess going back to this, if somebody made an arm that I really liked, I don't know that we'd make this. So one more thing to mention on all of our upper arms is we'll put the arm on our CMM and we'll figure out what angle the factory outer ball joint will sit at. And we do these arms, first operation is a 3-axis, second operation goes onto one of our pallet-loaded automated 5-axis machines, and we cut everything else. So every arm, our outer rebuildable ball joint is going to sit at whatever angle it did from the factory. And, you know, admittedly, it's definitely, no, it's not more time consuming. It requires a higher level machine to be able to kick things at angles. It requires a 5-axis machine. But if we're gonna make something, I want it to be as close to factory as possible. So we put that angle into every ball joint by op1 on a 3-axis, and op2 goes on a robot-loaded 5-axis machine. And at 4 in the morning, while everybody's sleeping and nobody's at the shop, the machine is running parts. So I have an assembled one down here. You can see we've got a top cap on this that has a grease zerk fitting on it. So it can be greased anytime you want. Rock crawler flex joint on this side, double adjuster with a jam nut and 2 pinch nuts. The pinch locks the outer, the jam nut locks the inner. You can potentially get away without the jam nut, but we don't want to take that chance. And I do know from Jason Shear on his Ultra 4 car, I made all of his tie rods with just a pinch on them, and we thought it was good. And after hard running, so for he does a bunch of testing, pre-running, everything's fine. Racing, we saw the physical joint move even with a much larger pinch. So we'll do a pinch and a jam nut just for that added security. I think that covers most. So this is kind of a line that we've wanted to release, and it's been kind of a back burner project for us. But this is going to be kind of a focus from now till the end of the year. We have a couple other platforms in the works that we're going to talk about soon. But we really want to release a set of arms and links for our stuff, designed specifically for our stuff, because I have seen things where someone has an upper A arm from company X and our portal, and at full compression and turn, the portal is physically touching the A-arm because we add extra material around the upper ball joint. That to me is like, it's one of those things that like we can design around factory components because we have those and we know those. I can't design our portal to work with every upper A-arm on the market. If you cycle your suspension and you have an upper A-arm on it and everything clears, then you're good to go. But what I can't do is go buy every arm on the market and test it with our kit. If you're going to mix and match parts from different companies, you really have to take your time to cycle everything and make sure everything clears and make sure things aren't binding. So we just made a decision internally that, okay, I know guys want aftermarket arms and links. I think that we can improve, and there's something that I would do different. So we said, okay, well, let's go ahead and do this. And I think there's just going to be a market for it because I hope that I'm not alone in my, I don't want to say hatred or disdain, it's not. I love uniballs, I love Heims, I think they belong on race cars or they belong in something that gets prepped. It's not really a race thing, it's a prep thing. So if you don't want to change out your joints on a frequent basis, take a look at our arms, take a look at our links, and any questions on this stuff, throw them in the comments. I will get them answered. And I think that's it. We'll catch you guys on the next one. We'll update you soon as to all of the other, I guess I could talk about the other platforms. We're doing 4Runner, so 5th gen 4Runner, 4th and 5th gen 4Runner, 2nd and 3rd gen Tacoma, and all the other platforms that fall in there, like FJ Cruiser, that stuff. All of the new Toyota platforms and Ranger Raptor. We're getting into Bronco for upper arms, and stay tuned on Land Cruiser 200 and 2nd gen Tundra. We will be making arms for those as well to support a new product. So I think that covers most of it. Any questions, throw them in there, and we'll see you on the next one.